In this particular lab, you're going to be looking at the relationship between electric field and distance from it. So let's take a look at what we know. Okay, one thing that we know is that when we move from one point to another in the direction of the field line, that the voltage changes. And so this diagram at the top here is showing how the voltage changes as we move from a positive charge outward. And that voltage is related to the electric field, where the electric field is equal to the voltage at that point divided by the distance to that point. So we can rearrange that equation and get an equation for the electric field strength as the voltage divided by the distance. And in our lab, we're using the variable R instead of D, so just keep that in mind. And if we were to make a graph of the strength of the electric field as we move away from that point, and we graph electric field on the y-axis and distance on the x-axis, we're going to get an inverse square graph where the slope is the voltage at a particular point. So you are going to go to this applet here, and you're going to turn on the electric field, and you're going to turn on the values and the grid, and you're going to just place a positive charge somewhere on their thing, and so you can see the electric field. And you don't even have to have that on, but just so that you can see the electric field points away and it gets weaker, right? It should be an inverse relationship. So the shorter the distance, the bigger the electric field, as you can see with those vectors. All right, so next thing you're going to do is you're going to turn on sensor, and you are going to put the sensor in a position, and you are going to measure the electric field at that position. And then you are also going to measure the distance to that position. And so I like to move this right here, and I'm going to try to keep it on the same line. So I'm just going to put this here. Oops, my bad. And I'm going to take my sensor, and I'm going to make sure that my sensor is as close to 0 degrees as I can get it. So it's just right beside it to the right. And so my first point will be a distance of 0.487 meters and 37.4 volts per meter for my electric field. And then I'm just going to move my sensor out to another location, out a little further along the same line. I want to try to keep it as close to the same angle as possible. It's kind of hard to do, and but we'll just do the best we can because we want to do it along that electric field line. And so this would be 8.94 volts per meter at 0.992 meters. And as you can see that as the field strength, as we get further out, the field strength goes down. And so you're just going to be verifying that in this lab. So you should expect that when you put the distance in meters on the x-axis, and then you plot the electric field on the y-axis, that you should get an inverse 1 over x graph. And so that's the curve fit that you want to add to your graph. And then you're just going to write the definitions in the lab for electric force and electric field so that you know the difference. So we're just kind of just verifying that relationship, that as we move out further from the point, the electric field diminishes. It's that simple. It's not a really hard lab at all.